Good afternoon, statisticians. We've made it all the way to probability. Why is probability not first? Who knows? But hopefully I can make this as clear as I can. Probability, I think, is one of the better things to explain. So I'm going to give you a couple examples. I like the dice one I did before, just to kind of show you the differences between and or and all the stuff with it. So, and I'll do the homework problem. So I'm sharing my screen. Where am I at? I am here in Intro to Stats. We're all the way down to 4.1 probability. So before I go through these problems, let me just show you probability. Probability people struggle with, but we're not going to struggle. We are not. And every answer that I'm going to do, I'm going to show you how to do it in multiple ways. Isn't that nice? So probability, the one formula to make it make sense to you for whatever we're doing, it's always what you want to get over the total amount. That is it. That's the only formula you need. Whatever we want to get over the total will give us the probability. This will produce a fraction, which we can divide, or a fraction, which means fractus or broken, which will give you a decimal. Then if we take that decimal and we multiply it by 100, we're going to get our percentage. So for each one of these, whatever answers we do, we either get a fraction, a decimal, or a percentage. Remember, percent, whenever they say that to you, means divide by 100 out of 100. Fractus means broken, which means cut in half, and this is your decimal. So all these are for probability. Now, here's a common one. So end, if we need two things to happen in probability, it's really hard, so we multiply them. Because we're multiplying fractions or decimals, it gets smaller because it's more challenging. We have or for probability, it's easier to get them. So it's like adding. So I did dice before. I'm going to do another dice problem just to make this probability be your best friend. So let's say, what is the probability? We're going to have two dice. And I break up the dice just to make it look more simple. All right, here are my dice. 1, 2, 3, 4. Sorry. 5, 6. Let's try that again. 1, 2, 3, 4, 5, and 6. So we're going to do the probability. We'll do or first, which is going to be adding, and then end, which is multiply. So what is the probability of rolling a 4 or we're going to have two chances of 4 or a 5. Okay, these are going to be the two things that we do. It's a 4 or a 5. So to roll a 4, you can get a 1 and a 3, a 3 and a 1, 2 and a 2. Look, a 1 on the first, a 3 on the second, a 3 on the first, a 1 on a second. But notice that if I go a 2 and a 2, it doesn't matter which way I go since they're a match. That's why it's only one way. See how there's 3 sets of circles? That's what it is. So this is going to be 3. So to roll a 4, it's kind of hard to do. That's a 3 out of 1, 2, 3, 4, 5, 6, 2, 2, 3, 4, 5, out of 36. So that's the first one. Now we're going to add this to a 5. To roll a 5, I can do a 1 and a 4. A 4 on the first, a 1 on the second, a 2 on the first, a 3 on the second, and then a 3 on the first and a 2 on the second. This is 1, 2, 3, 4 ways. 4 out of 36. Now, when you're adding fractions, you just add the top and keep the bottom. We're left with 7 out of 36. This number doesn't really go into it, so this is as small as it goes. There's our fraction. To make it into a decimal or a percentage, all we have to do is, guess what? Divide. So 7 divided by 36 is 0.919. We're going to leave the decimal. Then if I multiply it by 100, I get 19%. Ta-da! All right. So that's rolling a 4 or a 5 on two dice. Now let's say we want to multiply this. This means I need to roll a 4 and then a 5. So I got to get a 4 on dice 1, and then I got to get a 5 on dice 2. Or I need a 5 on dice 1 and a 4 on dice 2, however it is. But this is, if I need this and this to happen, it's harder. So a 4 and a 5, we have to multiply them. So this is 3 out of 36 times 4 out of 36. Well, what is 3 times 4? That is a 12. And what is a 36 times a 36? Because fractions, you just do top times top, bottom times bottom. This is going to be a big number. 36 times 36. Boom, 1296. Now we should be able to simplify this. If we can divide it by 12, let's see. I have some faith that we can cut this by 12. Ta-da! So if we divide top and bottom by 12, how did I know? It's because 12 goes into 12 and 12 goes into 96. 12 goes into this, it's 10, and then this goes into 96 8 times. So we know this is divide by 12, which is going to be 1, divide by 12, which is 1 over 108. See, it's much harder to do one and then the other. And how do we change that 1 over 1 over 8? We do 1 divided by 108. So it's 0.009. So 0.009 or 0.9%. So this is the other way. And I hope that little probability intro was useful. Notice the probability is either 0 to 1 or 0% to 100%, however you want to slice it. So you can think about it going from 0 to 1 or 0% to 100%. Can't have more than 100%. You can't have more than 1 when we're talking probabilities. But I thought that would be a nice little intro for everybody. So guess what? Let's look at the book. Let's look at some problems, and we're going to 4.1. So I'm going to go to my math lab. And I'm going to open the book, and I'm going to go to 4-1. Go to e-text. And I'll look at the book, and then I'll do some of the problems. Considering tomorrow is Monday, I'm hoping I get more work from folks. Some people still haven't sent me work. Please turn in your work. If you fall behind, I'm only going to accept it if you give me a good reason. Okay, so please, please, please try to get your work done or email me. I'm more than happy to help you with it. Here's 4-1. Basic concepts of probability, such as chance, testing the difference of 20 different births. That's fun. Hypothesis testing. We claim that gender selection has a greater likelihood of a baby being a girl. All right, so here's some words. An event is the collection of results or outcomes. A simple event cannot be broken down into smaller components, and the sample space is all your possible outcomes. These are nice little definitions. So we have our event and we have our sample space. So if it's one event, a simple event, it's just going to be boy or girl. Now, if we have 3 births, we have boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy. To figure this out is actually what's called a permutation. So we don't, whenever the order matters, it's called permutation. So I might as well teach you 2 more things because why not? So this is the difference between permutation to find those sample spaces. And your calculator does this for you, NPR, and combination, which is NCR. And this one, permutation, means placement matters. See, that's why I have the P there. So placement matters. I always think about it when I look at the word permutation. I always see placement, right? Placement matters. That's how I know the order matters for that boy-girl thing. And for this one, NCR, it doesn't matter. Order does not matter. So here we go. I'm going to write, I don't care about order. It's a really good way to remember it. So permutation, placement matters. I don't care about order, commutation. Formula is pretty crazy. It's n factorial over n minus k factorial. And I'll tell you what these mean and what factorial means, but your calculator does it for you. This is n factorial over k factorial times n minus k factorial. So, what is a good way to think about this? I think I'll make an example with t-shirts and then we'll do them. So what does factorial mean? If I have five, it's 5 times 4 times 3 times 2 times. So here's the common example. Got 10 people running a race, n is the total, and k is the groups. If I have 10 people running a race, how fast can I give out the gold, silver, and bronze medals? Well, this is 10 factorial over 10 minus, well, how many medals do we have? Gold, silver, and bronze. We have 3 groups. So it's 10 factorial over 7 factorial. So this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the bottom is 7 times 6 times 5 times 4 times 3 times 2 times 1. Cross out the matches. How many ways can I give this out? 10 times 9 times 8 is 720. I made up this thing called the slot method. So gold, 10 people can win the gold. I hand it out. How many people can win the silver? 9. And win the bronze, 8. Matches up 720. Now, if you use your calculator, you can see that there's a button for it. There should be a button for permutations and combinations that just do it for you. I mean, I thought there would be. Well, this one doesn't have it, which is kind of annoying. Maybe if I'm on programmer, nope. Maybe if I'm on standard, nope. Maybe if I'm on scientific, what if I make the standard one different? Nope. So that's kind of annoying. It doesn't do permutations and combinations. It should. Okay, well, I'm not going to make you take my word for it. So ready? Scientific calculator. These are all weak. Thought it could be in trig. No stats. Here it is. Here's the P and the C. So here we go. So we have 10 P3, which we know should be 720. 720. Ta-da! All right, so let's get back into it. So now let's say we don't care about the order. Let's say I give out t-shirts. So the bottom of this is going to be t-shirt, t-shirt, t-shirt. See, they're all the same. You can't use this little method because they're all matched. It doesn't change. This is 10 factorial over doubles in all the groups. So what do we got? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 1. Then we have 3 times 2 times 1. Then we have 7, 6, 5, 4, 3, 2, 1. It will always be, when the order doesn't matter, the doubles don't count. So these get knocked out. 9 goes into 3 3 times, 8 goes into 2 4 times, 40 times, it's 120 ways. So that's how I knew exactly it was. So we had 6, right? And there were 2 groups. So you go back to your textbook, you can see if we have 2 different groups and we have 3 births, right? 1, 2, 3, 4, 5, 6, 7, 8. How do we know it was going to be 8, right? How can we tell that it's going to be 8? Well, if we're doing this 3 times and it can only be boy or girl, guess what? The order, because we can have boy, 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 girl, and we could have girl, boy, boy. Nope, we don't. So that means that the order doesn't matter. So if we were doing this, we would see to get the 8, to get the 8 methods on the 3 births, you would be able to just see that it's there. This thing keeps like noting multiple times, and that's what it's going to give you. It notes a probability, specific event, the probability of A occurring. Notice it's going to be from 0 to 1, 50-50 chance, unlikely. So here we go. Here's some good stuff. 3 common approaches to finding the probability of an event. Because the last thing we want to do is like write them all out, because it just takes way too long. It is going to take too long. So here we go. The number of times A occurs, the number of times the procedure was repeated. So that's a really good way to think about it for this relative approximation of probability. The number of times it occurs over the number of times the procedure was repeated. The number of ways A occurs, S, the number of different events. So this is what I was doing. This is like what you want out of the total. This is the procedure repeating. Then we have subjective probabilities. The probability of A is estimated by using the knowledge of relative circumstances. Always assume the outcomes are equally likely. Okay. When trying to determine a crash, cars each year and crash, then we find them. Okay. Okay, cool. I like these examples. So for a recent year, it's 0.0480. This one's going to be 0.0000200. And so all of these will really help out. All right, so we have 39 million airline flights, 16 crashes. So what do we want the flights? What do we want on the bottom? Over the total number of flights. So it's what you want over the total. We divide it, we get the value. And here we go. So includes the 8 equally likely outcomes for the boys and girls. And you can write them all, I guess, if you really want to. The reason why this is a combination, right? Why is this a combination? Because it doesn't matter if I go boy, 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 or boy, boy, boy in this way. It's like the first beat, the second beat, or third beat. It's just one. That's why the order doesn't matter, right? That's why this whole thing is going to be less. So we can use the combination formula for this to get 8. We know that we have 3 boys and 3 girls. So what are the totals? We have 6 of each, and then we divide by the total. That's how we're going to get that 8 down there. Okay. Yes, there's ghosts. No, there's not. So we have to get the total, and then we divide yes by the total. All right. I think we're ready to just do the problems because I think that makes sense. Sometimes we need to find the probability that event does not occur. That's the complement or A bar. So that's just if they ask you if it doesn't occur, you can take the regular probability and subtract it by 1. So 1,782 use the internet, 220 do not use it. So we have to first get the total, then to figure out to not use it, we do the not over the total. The rare event rule. Okay, so here's some different stuff. So probability is very small that observes significantly less than or significantly greater than what we expected. So if we have a significantly high number of successes, if the probability is less than that, okay. Here's a review. This is does not. This is the probability of an end. Impossible event never happens, but always occurs. It's 1 and it's between 0. Sweet, we get to do odds. Odds is always it's a little harder for people to understand. Well, one maybe because it's gambling, but whenever you have odds, when they're telling you odds, it's always yes, this will happen versus no, it will not. There's no total in the odds. Okay, so what does that mean? So if they say your odds of this team winning, right? The odds of this team winning are 3 to 5, right? You got 3 to 5 odds. And they use the word 2 a lot. 3 to 5 odds. What does that mean? This means obviously it's working. We're gonna win, right? Is 3. 5 is we lose. Okay. So what is this? Our probability of us actually winning? It's 3 out of 8. That's what it means when it says odds. That's how they work. So we can do 3 divided by 8. 0.375 times it by 100. So what are the chances? If it's 3 out of 5, it's 37.5% of us winning or working out. That's what odds means. That's how it works. So it's yes, then no. It happening, it not happening. The reason why it's harder for us is because there's no total for this. So it says A to B, where A and B are integers. So 16 it happening, 4 doesn't happen. Actual odds is it happening. The ratio of not happening to happen, usually expressed by A and B, where A and B are integers. Reduce the largest factor. If A is 16, express the odds of 16 and 4. Now, the odds in favor of an event occurring is the ratio happening versus not happening. Okay, so that's actual odds in favor. That's the one that I showed you was odds in favor. And then the first one is odds against. I don't know why you would want to see odds against something occurring, but that's what they gave you first. Now, payoff odds is something that they do a lot. Okay, so that's the amount of your net profit. So it's versus the amount that you bet. So this is whatever value you're going to get in versus the amount that you bet. Notice that this is the only one that has a total. The payoff odds is the only one that has the total. So I might as well do this whole one for you in case it's confusing. So you bet $5 on a 13 in roulette. Your probability is 1 out of 38. But the payoff odds are given 35 to 1. So find the actual odds. All right, so here we go. We're going to do that. So find the odds against the outcome of 13. So the odds against. So they're talking odds against. That means you lose is first versus you win. So what is the chances of us losing? Our chances of losing is 38. Sorry, it's 37 out of 1. Because of winning, it's 1 out of 38, which means our total is 38. That means losing is 37. And winning is 1. So that's 37 to 1 odds against us. The payoff odds are given 35 to 1. How much net profit would you make by betting $5 on 13? So what does this mean? Net profit. So if we do, if this is against us, the net profit is what we're looking for, right? So for our net profit, all we have to do, oh sweet, the first one was right, 37 to 1. And then we know it's 35 to 1. So we just have to multiply it. That's all we have to do. So to multiply it, it's our $5. That's basically it. And then it's 35 to 1. So it's basically just 5 times $35. Here's the 5, carry the 2, 50. We should win $175. Yeah. So after winning, the total amount collected would be 180 for a net profit of 175. So how much are we getting back? 180, but our net is 175. The casino is not operating for profit, and the payoff odds were changed to match the actual odds against 13. How much would you win? Well, basically it'd be the same thing, but if it's the actual odds, it'd be, I believe it's going to be 5 times 37. Let's see what the answer is. Here it is, 185. Ta-da! So that's how it works. Oh, we made it to the end. So I'm gonna do a couple of these. 1 through 3, 5, 9 through 12. None of them should be too crazy. If they're too hard, just let me know. So 1, 2, 3, 5. Start with 1. California lottery. Let A denote the placing a $1 straight bet on the California daily 4 lottery winning. There are 10,000 different ways you can select the 4 digits with repetition allowed. In this lottery, only one of those 4 digits will be the winner. What is the value of A and what is the value of not A? So if there's 10,000 different ways, you can select it. So if there's only one way to win, I believe this is your A is 1 out of 10,000 because there's 10,000 ways and we picked 1, and not A be everything else. So this is of us not winning would be 9,999 out of 10,000. Isn't that exciting? Rewrite the following statements of the likelihood of rain is expressed as a value between 0 and 1. The probability of rain is 25%. The probability of rain is 0.25. That's number 2. All right, let's go to number 3. Number 3, remember, it's always going to be what you want out of the total. We got a 6-sided die. The outcome is a 5. Well, I know that there's a 5 on the dice. But there's only one of them, right? That's why it's 1 out of 6 still. Still going to be 1 out of 6 or 16. Well, it's rounded to 17%. We divide it. Find the probability when a coin is tossed. The result is heads. Well, there's 1 heads out of heads and tails, so that's 1/2 or 50%. And for letter C, the outcome 7. I don't have a 7, so it's going to be a 0. So that was the first 3. Hopefully it was pretty clear. Let's look at number 5. Which of the followings are probabilities? Well, remember, they have to be between 0 and 1 or 0% and 100%. 0, yes. 3/5, yes. 5/3, it's actually bigger. It's actually turning around. Remember, 5's on top, 3's over here. This goes into ones. So it's 1 and 2/5. 1 and 2/5. 1 times 5. 1 and 2/3. My bad. 1 times 3 is 3. So how you go back the other way. 1 times 3 is 3. Plus 2 is 5. So this is going to be 1 times 3 plus 2. That's how 1 and 2/3 goes back to 5/3. But either way, this is not a probability because it's bigger than 1. Can never have a negative probability. So this one, this negative 0.25 is also not a probability. 250%, that's bigger than 100%. So this one's also not a probability. 7/3. In my odds are 7/3. That means it doesn't say which way it is, but that's yes versus no. So this is just 7 out of 10, 70%. So this one is a probability. The number 1 is a probability. 50/50. I don't know why it's written that way. I'm going to go with yes. It looks kind of weird, but I'll take it. 5-to-1 odds. That's yes versus no. This just means it's 5 out of 6. That totally works. We have 0.135. That's between 0 and 1. That works. And this one, 2.017, this is not between 0 and 1, so this one does not work. So look them over. check them, see which ones really make sense for you, or if they don't. I'll do a couple more. I'll do 9 through 12, but the rest is going to be on you. So hopefully this is getting kind of clear. I mean, I hope. Assume that 500 births are randomly selected. Use subjective judgment to given the number of girls as significantly high, low, high, neither. Okay, so we know it should be at 50-50 for boys and girls. So if I have 53, I'm gonna go with no. So I'm gonna go with C. This is neither. 35, that seems significantly low. So that's an A. 75, that's significantly high. So I'm gonna go with a B for that. And then 48, I'm gonna go with C because that's the same. That was so fast, I might as well do one more. Let's look at 21 through 24. All right, we finally got a problem. I was waiting. I knew it would happen eventually. Microsort's Y-sort gender selection technique is designed to increase the likelihood that a baby will be a boy. That's creepy. At one point before clinical trials of the Y-sort selection technique were discontinued, there were 291 births consisting of 239 boys and 52 girls. Based on these methods, what is the probability of a boy used? Does it appear that the technique is? I think it is. I definitely think yes. I'm going to go with yes. Just remember, it's always what you want over the total. We want a boy. How many boys did we get? 239. What's the total? 291. That's a lot of baby boys. So what is the probability here? 239 divided by 291. It's 0.82, which we know is 82% shot. So that's why I think it was successful in making boys, because the general was 50%, we're way higher. Let's do one more. 22. In a circle survey of 3,000 adults, it was found that 17% of respondents do not carry any cash. Based on these results, what is the probability carries no cash? So, and does it appear that most adults carry some cash? So 17% do not carry any cash. So obviously most adults carry some cash. So what does this mean? How do we go backwards? So basically we already have the probability, right? And we have the total. We just need what we want. So we just go backwards. So the probability is 17%. What we want to get is our X and our total is 3,000. So this one we go a little backwards. So first thing, 17% we divide by 100. That's 0.17 equals X times 3,000. Put it over 1, make them both fractions. I always make that like a thorax, these little antennae. And butterfly rhymes with cross multiply. This is 1x. This is 3,000 times 0.17. I would just do 3,000 times 17 and then move the decimal. But if that's too much for you, 3,000 times 0.17. There were 510 people out of the 3,000 who did not carry cash. Based on these results, what is the probability that randomized sample carries no cash? 17%. Does this appear that most adults carry some cash? Oh, well, I didn't answer it. I give you more information. So it's yes, most adults carry cash. Let's do one more. Let's do 23. When Mendel conducted his famous experiments on peas, sampled offspring 428 were green, 152 were yellow. Based on those, estimate the probability of offspring pea that is green. Okay, is the result reasonable? So we have to see if it's close to 75%. They don't give us the total here. We have to make the total. It's still what we want. over our total. But here they don't give us the total, so we have to add them together. So 152 plus 428. And what we want to get is the green piece, 428. 152 plus 428 is 580. And 428 is on top. Let's see how close it is to the 75%. So 428 divided by 580 is 0.737. If you round it up, we got 0.74 or 74%. Great job, Mendel. We did it. All right, so I hope that was helpful. I'll give you some to try yourself. I knocked out just about all of them. I left you 4 to do. Good luck, and hopefully this was useful for probability. If it wasn't, just let me know. I'll try my best to explain it better. Take care.